Welcome back, class, and thank you for joining me for this next Flip to Classroom video. So today we're going to move on to section 3.3, Systems of Inequalities. So we're still dealing with our systems. However, this time, instead of solving equations, we're going to be solving inequalities. Now, something to realize, the only way to solve a system of inequalities is actually graphing. So every one of these we need to solve by graphing because we're going to be getting a shaded region. This time a region is going to be our solution, not an intersection point. So let me demonstrate what I mean. So here you can see we have our system of inequalities. So the first thing I need to do is graph both of these inequalities. So you can see the similarity between solving systems of equations. You needed to graph both equations. This time we need to graph both inequalities. And as we know, the only way to graph is to solve for y. So I'm going to take that top equation, that 2x plus 3y is less than 12, and I'm going to solve that for y. So I'm going to start by subtracting 2x from both sides. So I'm going to have 3y is less than negative 2x plus 12. And now I'm going to divide everything by 3. So I get y is less than negative 2/3 x plus 4. All right, so mission accomplished. I have my first inequality solved for y. So now I can actually graph it. So I'm going to graph this one in blue. So I start up at my y-intercept. So I'm starting up at that 4. Now I'm using my slope of negative 2/3. Down 2 over 3, down 2 over 3, down 2 over 3. I can even go in the opposite direction. So that's where my line is going to be. Now remember, before I draw in my line, I need to check. So notice here, strictly less than. Strictly less than means I'm not getting a solid line, I'm getting a dashed line. So I'm dashing my line, and if y is less than that line, where is less than that line? Well, less than is everything here. So there is my first inequality. Now, I'm also going to graph the second inequality. Now, the nice thing about the second inequality is it's actually already solved for y. So I can actually graph this one right away. So again, start at your y-intercept. So I'm starting at negative 2, slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. I can do that in the opposite direction. So there's where my line is going to be. And again, I have to stop for a second to analyze what my inequality sign is telling me. Greater than or equal to. So that or equal to piece means I'm getting a solid line. And a greater than means I'm shading above my line. So everything up here is going to get shaded. So what does that mean? This kind of looks a little bit messy right now. There's a lot of shading going on. So what I want you to see is where is the actual solution? Well, the actual solution is where it's double shaded. All right, so where it's double shaded, we have our dotted line there, solid line here, then everything in this region that I just highlighted, everything in there is our solution region where it is double shaded. Now, you will have to be able to also identify specific solutions in the system. So what that means is you just have to be able to pick out points that are actually true for the system. So what I mean by that is you can pick a point that is clearly inside both regions. So there you can clearly pick the point -1, 0. This in the solution region. you can pick a number that is on the line. So there, if you have a solid line, your point could be on there. So that 0, -2 would be a solution. The only points you cannot pick are points that are not in that shaded region or that lie on the dotted line. Any point on that dotted line is not going to be part of the solution set, because remember, that's what the dotted line really means, is that it doesn't actually work. So I ask you for 3 specific solutions. You're looking for any solutions clearly in the double shaded region or on the solid line boundary of that shaded region. Okay? Now, let's move to our next example. Now, here, I'm sorry, I don't know what happened when your packet printed. However, the equations themselves did not transfer into the packet. So make sure you take a moment and write down those 3 equations for me. All right? Now, for this, I'm going to start with this one in red. So y is greater than the absolute value of x plus 3 minus 5. All right, now remember, absolute value. So to graph these, first we have to find that vertex. So remember that x plus 4 is shifting it 4 to the left. Positive means to the left, and minus 5 means down. So my vertex is going to lie right there. And then remember, we follow our slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. We got that line. And then remember, it gets reflected in the opposite direction. So the up 3 over 1, remember also we end up reflecting over that vertex. And that's how we obtain our V shape. Now, before I draw my lines, remember, I need to see what type of line I'm drawing. So here, strictly greater than. Strictly greater than means it is a dashed line. And that also means greater than means I'm shading above. So I start at the vertex and I think, where's above my vertex? Well, everything inside here is above that vertex. So I get everything in there shaded. So there's my inequality for the absolute value. Next, I'm going to focus on the y is less than or equal to 5. All right, now, y. Remember, when you just have y and a number, remember that relates to a horizontal line. So, less than or equal to, well, that means I'm getting a solid line. So solid line up here at 5. And where is everything less than that? Well, everything less than that is going to be here, underneath it. All right, final one. This time we have 3 we have to graph. So x is greater than -4. Remember, that is going to give you a vertical line. It's a vertical line. Now, again, analyze it first. So vertical line, x is greater than -4. So strictly greater than means dashed. And where is greater than that? Well, greater than that is everything up here. All right. Now, when you're shading this much, again, it is really easy for this to get messy. So I want you to think about, where exactly is all of this happening? Well, let's take a look. We start at the vertex. We have our dashed line there, solid line there, dashed line there. So inside here is where all 3 converge. Okay? And again, making clear where you have solid and dashed lines. But that's where all 3 end up coming together, right in that region right there. So if we're being asked to identify solutions to the system? Well, you just have to look to see where is this occurring. So if I look, -2, 2 is in that black region. -2, 3 is going to be in that black region. -3, 4 is going to be in that black region. So all you have to do is identify points within that shaded region. And again, it either has to be within the shaded region or on a solid line boundary of the shaded region. Those are the only points that you can choose. All right, so to continue our conversation here, we're going to go through 2 word problems. Now, the focus I'm going to put on these word problems is finding the equations. Once we find the equations, then I already have the graphs pre-done to show you what they look like. So, example 3. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for the balcony seats and $30 for the orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? Now with word problems, again, the way that I focus on word problems is first I look at what is the question. How many of each type must they sell? So my 2 variables have to answer that question. So, well, what do they mean by each type? They mean type of seat. So X is going to represent number of balcony seats. So Y is going to have to represent number of orchestra seats. All right. So we have our 2 equations, or we have our 2 variables. Now we have to start working on the equations. The first one is going to represent a money equation. They want at least $30,000. How are they going to get that? Well, $20 per balcony seat. So the money they're going to make is 20 times the number of balcony seats that they sell. For the orchestra seats, they make $30 per seat. So again, the money they're going to make off of that is 30 times the number of orchestra seats that they sell. And they want at least $30,000. At least means it has to be greater than or equal to $30,000. In a second equation, the center has 500 orchestra seats. So what that means, now Y is the number of orchestra seats. So what is that telling us? That they have 500. Well, that means in terms of the number of orchestra seats that they can sell, they can only sell less than or equal to. They can sell up to that 500, but they can't sell more orchestra seat tickets than they have seats. So we have to cap it off at that 500. All right, so that's how we can construct these 2 equations. So now we have our system of inequalities. And now again, the only way to solve this is by graphing. And I'm not going to make you graph this by hand. This one would get pretty messy. However, I do want you to see how you'd go about solving this. First, notice that top equation. The top equation, you would have to solve for y. You'd have to get y by itself. So what you'd end up doing is subtracting the 20x over, so you'd have 30y is greater than or equal to -20x plus 30,000, divide by 30, so you have y is greater than or equal to -2/3 x plus 1,000. So if I were making you solve this, those are the 2 graphable inequalities that you could use. And now just to show you what that looks like, here I used an online calculator to end up graphing this for me. And again, the solution region that you're looking for is everywhere purple in here, okay? So this region right here would be your solution region. And again, we let X represent balcony seats, this represented orchestra seats. So if we wanted to know how many we had to sell in order to make the profit we're looking for, I could say, all right, I could sell 1,000 balcony seats and 400 orchestra seats. That's one possibility. I could also sell not many. So I could sell 1,400 balcony, and that would be 200 orchestra. So you can see it works the same way. As long as you're finding points that's inside that region, you're finding a solution that works. In this case, what we're looking for is the solutions that will get us at least that $30,000 of profit. All right, let's go to our last example. So, pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? So, how many toppings of each type? Again, that is going to tell me what my variables are. So, what are the types of toppings? Well, X is going to be number of veggie toppings. Y is going to be number of meat toppings. All right, so again, by looking at what the question itself is asking, will tell you what your variables need to be. So now we need to take a look at what this is telling us. So first, you want at least 5 toppings. All right, so at least 5 toppings. So that means the combination of veggie and meat toppings, I want that to be at least 5. I need that to be greater than or equal to 5. All right, so there's our first step. Next equation is cost. So we have $10 to spend. Well, what are we spending? Well, $1 for each vegetable topping. So $1 for every vegetable topping we get, and $2 for every meat topping that we get. And by telling us we have $10 to spend, what that's communicating to us is whatever we're spending has to be less than or equal to that 10. All right? We can't spend more than what we've got. So when they give us that amount, that's telling us that we can only spend up to that $10. So again, this is our system that we would have to solve now. And again, by solving inequalities means graphing them. So in order to graph these, remember what you would do is get y by itself. So for this one, that means subtracting x from both sides. For the bottom one, it means subtracting x and then dividing by 2. So that would be our new graphable system. Solving both of them for y would give me that. And so again, to look at the pre-done graph that I have, this represents that solution. All right, so again, looking at the double shaded region, and again, when we're talking about physical things, we have to be in the first quadrant. But our solutions will be everything inside that double shaded region. With again, X representing veggie toppings, Y representing meat toppings. So we were trying to look for possible solutions. Well, here, there's a solution. I could get 4 veggie and 2 meat toppings. What if I did this? I could afford 8 veggie with 1 meat. So if you're looking for possible solutions, which was the point of graphing this, all you have to do is identify points within that double shaded region. All right, so I think I'm going to call it good for this video. So thank you so much for joining me. So please make sure you have all of these notes taken down and ready to show me in class, and then we will be ready for our practice work. So again, thank you for joining me.